Welcome to solverfy.
So we are standing at a distance d0 of 1.9 meters away from a mirror, and we're asked to find the curvature of the mirror when we notice that the magnitude of the mirror is equal to 3. So you're 3 times your normal height when you look in the mirror. Okay, well, the radius here is going to be equal to 2 times the focal length, since for a curved mirror, the focal length is half the radius. So that means we need to find focal length. So to find focal length, we can use the fact that 1 divided by the distance to the object plus 1 divided by the distance to the image is equal to 1 over f. Okay, well, to find this, then we need to find the distance to the image. We can use the magnification to do that, because magnification is equal to negative distance to the image divided by distance to the object. Therefore, the distance to the image is equal to negative magnification times the distance to the object, which are things we both know, so we can substitute that in for the distance to the image. So solving for focal length, we find that the focal length is equal to the distance to the object times the distance to the image divided by the sum of the distance to the object plus the distance to the image. Okay, so we're going to plug what we found the distance to the image to be, which is negative the magnification times the distance to the object in here. So we have distance to the object multiplied by negative magnification times the distance to the object divided by distance to the object minus magnification times the distance to the object. Okay, so plugging those values into this expression, we find that this is equal to 2.85 meters. So our focal length is equal to 2.85 meters. So if we plug 2.85 meters into our expression for radius up here, where I just pointed with the arrow, we find that the radius, we'll just write this down here, is equal to 2 times 2.85 meters, which is equal to 5.7 meters. And we can box that in as the solution to our question.